Go to the physics and engineering sections of a technical school's library, and you'll see a huge amount of information on a wide variety of phenomena. Beyond drag, lift, and stretch, there are many other properties we could simulate. Friction, applied force, flow, elasticity, tension, normal force, turbulence, spring force, heat transfer, gravity, thrust, and so on. Computing these is done by what's called a dynamics solver. What you're seeing on the screen now are a number of different simulations done for all sorts of phenomena. A few of these are computed at interactive speeds, some are created offline. In either case, the rendering is separate from the physical computations. Typically, the way solvers work is that a tiny time step is chosen for the simulation, often smaller than the time represented by the frame. The effective forces in the scene are computed for this sliver of time and objects are modified. This process is done again and again, time slice by time slice. Small steps help avoid various types of errors. The area of physical simulation is wide-ranging and users can have different goals. An engineer or scientist may be making a visualization of a particular process, and so the simulator is aiming to be as realistic and true to the physical world as possible. If interactive speeds are not needed, then time slices can be exceedingly small and mostly dependent on how much compute time the user wants to spend. The other major area that uses simulation is for generating what I call plausible animations. These animations are not required to be physically correct. Rather, their goal is to look reasonable to the viewer. Just as we don't pick up on reflection maps not having perfectly correct reflections, there are plenty of errors that we don't notice or can rationalize away. Though using physical principles for the creation of effects normally gives the most realistic results, for interactive rendering we often have to make significant simplifications. There are also simulators for phenomena that are not based on physics. For example, flocks of birds in flight, traffic in a city, and crowds of people walking inside a building are all systems that can be simulated with some basic rules. The artist can also guide the simulation as desired, perhaps having characters run towards a particular location and jostle for position.